Hello, today we are going to talk about the D programming language. Let's look at the Wikipedia article about it. So it's also known as uppercase D, D-lang, created by Walter Bright at Digital Mars in 2001. Andrei Alexandrescu joined in 2007. Originated as a re-engineering of the C++ programming language. Contains functional aspects, is a compiled language, has a memory safe subset, uses garbage collection by default. Okay, and the reference implementation latest release is 2.100.2 from September 2022. The license is the Boost C++ programming language libraries license. Filename extension .d, official website dlang.org, and has 3 major D-lang compilers. So DMD, which is the reference implementation, the GCC GDC, and LDC. So LDC is probably the compiler front-end from the DMD reference implementation, plus based on the LLVM compiler framework, and GDC GCC is a D front-end plus GCC. Has been merged in upstream GCC in GCC version 9. Okay, let's read some more. Not source compatible with C or C++. Okay, it has many features. Closures, anonymous functions, mixins, compile time, metaprogramming system, which is rich inline assembler, SIMD extensions, document generation, built-in tests, object-oriented, imperative, syntax similar to the C programming language in the sense that it uses semicolons and curly brackets. So in this example, it declares a local variable, it imports the std.stdio, so all of the functions from this module. For each syntax, I goes from 0 to 10, write function line, placeholders, I and scaled of 1 of I. So a domain-specific language similar to printf, DSL. And in here it declares a function inside of another function, so an embedded function. This is the signature, so similar to C++ programming languages. Return type, list of parameters, name of function, body of function. So it will use the multiplier, which is 10, and then scaled of I equals 0. So scaled of 0 will be 0. Return statement. Introspection, invariance in object-oriented programming. Okay. Let's look at the web page, dlang.org. And let's install the compiler, a text editor, or an IDE, whatever we can find. I'm on Kubuntu 22.10, and then we'll run through some examples, and then we'll do at least one tutorial. Okay, so let's see downloads. DMD GDC LDC, we're going with default implementation, which is the DMD, official reference compiler, simple installation. Download. What are we going to use? Not Docker, because we want to run a IDE. I don't know, let's try with the tar-xz. It finished downloading, 21 megabytes, tar-xz, so tar minus xjvf. Are there any additional instructions? I'll be back in a second with an ID. Okay. So I'm on the official dlang webpage, which is dlang.org. I went to resources, IDs, right-click, open a new tab. And in here, it says that the preferred IDs are a plugin for Visual Studio Code, a plugin for Visual Studio, a plugin for IntelliJ IDEA, and then a standalone IDE, which is called Dexed. And then there's a list of other IDEs, and probably also integrations for your IDEs for your full-fledged text editor, such as Emacs. Okay, so I chose from the first block of IDEs, and I went with this one, which is standalone. So Dexed runs on Linux, IDE dedicated to the deprogramming language, has support for DMD, dub, DCD, dscanner, dformat, etc. And seems to be recent enough, so July this year. So I went right-click, open new tab, and this is the web page. And I also downloaded the decompiler official reference compiler. So I went download. I downloaded the tar.xz. So now in my directory I have two files downloaded. So this tar.xz, so DMD 151.0 Linux tar.xz, and from the ID I went with binaries for Linux 64-bit, which is dexed.version.linux64.zip. Okay, I extracted DMD tar.xz using tar-xjvf DMD. This thing. It extracted into a subdirectory DMD2, and then I extracted Dexed Linux zip, which is unzip, the name of the archive, and then the name of the directory, Dexed. Okay, so DMD2 is not something that you would install into /usr/local, because it doesn't have a subdirectory bin and it doesn't have a subdirectory lib. So it wants to stay into ~/.opt. So that's where I put it. I copied the directory DMD2, the one that I extracted, to ~/.opt, so this directory. And then Dexed is just one directory with the SO file and the executable, which is this thing, Dexed. So again, this is not a standard Linux /usr/local directory structure. So I just copied the entire contents of this directory, Dexed -x86_64, to where DMD is. DMD being the D language compiler. So in ~/opt/DMD2, I found it in Linux bin 64. So in here I copied this entire directory. So F5, okay, overwrite all. Okay. And now the executables are DMD, which is the entry point to the D programming language, so the D compiler, and Dexed, which is the executable of the IDE. Okay, so DMD says that it does not exist. Of course, it's not in the path. I can run it from here. So I prepared a two bash command lines. So one where I'm setting the environment variable path, because I guess DMD will try to find dub and will not find it in the local directory. It will probably search it into path or rdmd. Dexed might search for DMD, etc. So it's a good idea to have this directory where the binaries for the executables for the DMD distribution are in front of the path environment variable. And then the IDE, which is Dexed, refuses to start because it says that it cannot find its own SO file which is in this exact same directory. So Dexed cannot find the SO file that's in the same directory where Dexed is. So for that I'm prepending to the ILD library path environment variable the directory where I have copied the Dexed files. Okay. So I start a new console, and in here, in this first tab, I will have these two environment variables set correctly for my ID and DMD. Let's check. So indeed, the bin directory of DMD is the first thing in my path environment variable. And probably the same for LD library path. The only thing in LD library path. Okay. So again, let's see DMD with no // at the start. Let's also use which, so which can find DMD, which I don't like. I don't like this extra slash at the end. So I'm going to close console, start a new console, and now run these two command lines again. Which DMD, now it has the correct path. Previously it had 2 slashes in here. And LD library path looks okay. And path also looks okay, so no trailing slash. Okay, DMD shows a usage and version by default. Okay, let's look at the ID, which is called Dexed. It looks like this. About Dexed and tools information. So it could find dub. Let's have this side by side. So it could find dub, which is similar to npm, so it's a package manager. And not only, it also manages projects, DCD client and server, dub, the scanner, GDB and diff. It could not find DMD because it did not search for DMD in the path environment variable, but it wants me to go in there. So in Dexed, main menu, options, compiler paths. So I did that, options, compilers paths, and in the first possible place where it says DMD compiler, I search the full path of the compiler. And then I went apply. Okay. Let's try our luck with this integrated development environment for the D programming language. How do we do that? Okay, let's create a file. And let's start from the beginning. So the D programming language. Let's see this example if it works. So the extension should be D. File, open file, a.d. Okay, let's see the symbols. So it says that we have just one function, which is called main, which inside of it, so embedded inside the main function, it's the function scale defined. There's one local variable which is called multiplier, which should be const. And then it imports two modules, which just one module, which is std.stdio. Okay, compilation, compile file and run. It expects an argument. Not really. Okay, so it says compiling a.d. So it took a.d, use the DMD compiler. It says in here, successfully compiled to this executable. So in the same directory as a.d, the source code file, we now have a binary which is called A. We run Linux, Ubuntu 22.10. So there's no extensions, there's no a.exe such as in Windows. So A without any extension. Let's look at the type of the file. So it starts with ELF, so it's a Linux binary, ELF. Okay, what does file say about it? It says A is an ELF, 64-bit, Linux standard base, PIE, which is portable executable or something. Okay, it's an executable because it has the chmod bits set, so is executable. So X bit, and X bit. So all of the X bits are set for A. So it's not just a binary. All ELF files are binaries, but it's also an executable. x86-64 version 1 dynamically linked. What does that mean? So it's dynamically linked and depends on the SO files linux-vdso.so, libgcc_s.so, libc.so6, and ldlinux so2. Okay, the interpreter is ldlinux so2. GNU Linux 3.2, not stripped, so it has debug symbols inside. Okay, so if we run A, it says hello world starting from 0 up to 9 inclusively, and the second value is the first integer times 10. So 0 times 10, 0, 4 times 10, 40, 9 times 10, 90. Okay. Does it do line wrapping? There's no search in the options of the IDE. So tabulation width 4, right edge 80. Just a second. Okay. So I couldn't find the setting to wrap the lines. I don't like to scroll left and right. Okay. So the output the standard output that's written at the terminal when we run the executable is also available in Dexed IDE in messages. So in here, let's see if we have a debugger. Debugger start. The binary to debug is missing. Just a second. Okay, so the deprogramming language uses the package manager, which is called dub, and we should use dub to create a sample project, have our source code in there, and then the IDE will allow us to actually debug the resulting executable. So we go dlang dub in Google. It says that this is the official GitHub repository, so github.com/dlang/dub is a package manager and build management for the deprogramming language. There's a package registry. These are some of the packages, so 2000 packages can be installed from the D package registry using dub, which is the package manager for the deprogramming language. But also it has a package file format, and this is the official website, dub.pm. Says that you can start a new deprogramming language using dub. So let's do exactly that. So the executable is called dub, the verb is called init, and the name of the project is my project. Let's do that. I don't have dub in here, of course. I have it in here. Okay. It asks the question, do you want the package file, so the file that describes the current project, to be in the format JSON or in a domain-specific language or dub, and I go with the default value, which is JSON. Let's press enter. The name of the New project, my project, correct. Description, author name, license. In the example, it shows boost, so I'm going with that. Uppercase B. I try to put a space in here. Add dependency, so I'm not using any other third-party libraries. I'm using just the first-party libraries, the things that come with the DMD D programming language compiler. So I go with an empty list. Says that it was created successfully, a new project in the current directory under the subdirectory my project. Okay, and it has created a source directory with a file up.d inside. So let's look at that. It's the Hello World application. And I have selected JSON. JSON is a commonly known format, but does not support comments, while the DSL, domain specific language, SDL-lang, allows comments. Okay. And now it says that I can build, I can run, I can test the project. So let's go. I need to change to the new subdirectory, which is my project. I go build. Says that it's using DMD, and it has created a debug build configuration, has compiled that. So the resulting executable will have debug symbols, which is what we want, because I want to run the resulting executable in the debugger. Let me run it. So run also runs build probably, because I can see performing debug build. It has built, not rebuild, because it says up to date. If I want to rebuild, I should run run and force. Now it has actually rebuilt. It says building my project, not up to date my project. And then it's linking, so this is the compilation step. And then it's running the executable, which is called my project, which has written this thing to standard output. So let's look again at the source code. It says write line, edit source /app.d to start a project, which we can see at the standard output in my terminal. And what executable did it run? Well, not this, not this, not this. Yeah, this. And there's also a .dub build intermediate directory probably. In elf object file. So a .o file that will be then linked to generate the final executable, which is this thing, my project, which is an elf binary, and also an executable because it has the xmod bit set. Okay, and that thing probably is then copied here. So it says run in my project. which is the same thing as if I run the executable on my project myself. Okay. And now let's see if GDB can understand this thing. GDB minus 2e my project says no source available. Let's put a breakpoint in here. So C to continue without paging, C enter, and then let's get a GDB set breakpoint source file. So I need break, file name, and then number. File name is this, Ctrl-Alt-C, Ctrl-Shift-V, and then line number is 4. I go enter, and then I need to run. Okay, so it has run, it has stopped at breakpoint on line 4, which is line 5. The function's name is main in the D programming language, but then mangled to be available from the C programming language. It's underscore uppercase D and then main. If I try to break at the function with the name main in GDB, it will stop in another place. So let's do that. So it says that the breakpoint for the symbol main, the mangled symbol main, is in tilde/op/dmd/linux/bin srcd runtime import core internal entry point.d. I start GDB from scratch, and now it has stopped not in up.d but in entry point.d on line 29. Because this is the unmangled symbol D, the unmangled symbol main, and also the mangled symbol main. Okay, then we go continue in GDB, and it has continued to the unmangled symbol main, but the mangled symbol main underscore uppercase D main, which is in up.d file. Continue. It shows what's written to the standard output and then says that the process has finished. The process my project. Okay, Control D to exit. And now let's run this thing from the IDE, which is Dexed. I'm going to tell it to open the current directory. Which is which current directory? So it did not open that current directory. File, project, close project, file, open project, and then Q4 tut my project says that it wants to open files which are dub.jsons, so I selected dub.json, open, and now in the dub project editor tool window, I can see that the name is my project, license is Boost, description A minimal D, application, copyright the one space, author myself. Okay, so it can inspect the project, and it says that it's of type build configuration plain. And it says that there's just one source file. I double click on it to open in the source editor of the Dexed IDE. I put a breakpoint in here, and I go start with the debugger. Okay, so Dexed IDE has this separate window which is called GDB Commander, which shows us that the execution in GDB has stopped on line 5, so it it stopped on line 5, which is function underscore uppercase D main, correct file name, correct line, threads just one, correct call stack, well, the only call stack because there's other functions, C functions, C programming language functions that has called underscore uppercase D main. Okay. And then step over, and it finished. So a call stack that also contains main from the mangled main, so from internal entry point.d. Okay, I have continue debugging and it finishes. Okay, let's go next with our examples. Let's run it with a debugger. Start. Source file is more recent than the executable. Why would you do that? Compilation. Compile project. Successfully compiled. Debugger. Start the debugger. So it again does not stop anywhere because it says no debugging symbols found. So let's select the build configuration debug and build again. Compile project. says start performing debug, so it is in the debug build configuration. Compile linked, and let's use the debugger. And this time it has GDB code brick. Okay, so let's see again what we have here. One thread, simplified call stack, CPU registers, we don't use an FPU. Okay, so it says that the local variables are I, which is defined in somewhere in this function but not initialized yet. Multiplier, which is again going to be defined here but not initialized yet. So let's step to the next. Okay, so now multiplier has the value of 10. Okay. Step over. So it actually stepped inside of the function. So this is a function call scaled of 0. And then it stepped into the body of the function, which is return 0 times 10. Okay. Let me clean up some of the output from GDB. Options, debugger, show GDB output, show raw MI output, save. Let's restart the debugger. Clean. Start. We have the assembler view. Okay, so step over, enters the called function. Where is the output? Okay, so we have a debugger that steps in the correct places because we use the debug build configuration in the dub project. So it steps in here, then when scale this calls, steps in here. We can inspect variables of type integer. We cannot inspect variables or symbols which are in fact functions. Okay. So again, the syntax of the deprogramming language: semicolons, void main, which is entry point function, similar to the C programming languages, curly brackets, this is a block, this is a for each, this is a list from 0 to 9, so it excludes the last value. This is the iterator local variable, so I takes values from 0 to 9 inclusive, so not 10. This is a function. Are we inside the debugger? Where is the definition? Just a second. Okay. What else do we have in here? Let's look at arrays. I need to build. So project, compile project. Says reduce my sum template. Reduce is not defined. So I need to import more packages. Control S, project, compile project F9. I need to make sure that build configuration use is debug, to have debug symbols. Okay. Step over. So we have two arrays, A1 and A2, values from 0 to 9 and from 6 to 9. Pure functions, immutable, autotype, in here we declare an embedded function which is pure, so these are attributes. We say that this function does not throw and it's pure functional, so it doesn't have side effects, only receives value through parameters and only returns something via the return value. Does not change things on the hard disk, does not communicate with the networking, etc. Just takes this, processes them in memory, and then outputs this. And it uses pivot, which is defined as immutable. Okay. And then auto results. So this is automatically determining at compile time the type of result. It uses reduce. We cannot navigate to the source code from the standard library, which I don't know why. Let me try and see if I can do that. So DMD ~op/dmd2 where I installed the compiler. I trust Control V and first to include, hopefully the extension is D. Should be std algorithm. This is a unit test. Okay, I don't know how to find it. So reduce is a function which we're passing a closure to, and this is the operator for type parameter. So we're specializing reduce, C++ template style with this thing, this closure. And that might mean that so my sum only acts in memory because it's pure functional, and the parameters a1, a2 are known at compile time. So this thing might be evaluated at compile time. Might. I don't know exactly. Okay. That thing returns result. Or it specializes reduce by this thing. Delegate literal. With the same result, 15. Okay, so result. What type is result? We don't know, but its value is 15. Result is again 15. What is chain? chain is also a standard function. Just a second. Okay, so let's look at the function documentation. So I went dlang doc and then the name of the function. So let's look at chain. So it says std range chain. So from here, spans multiple ranges in sequence. Function chain takes any number of ranges and return a chain exclamation mark. Oh mama. Functional things to blow your mind off. Okay, we're not going to dive this deep for now. Okay, what else? Parallelism. So there's std parallelism, iota parallel. Let's look at this. Control S. We're inside the debugger. Let's stop the debugger. Project. Compile. Debugger start. And step to the next instruction. Let's put a breakpoint inside. Stop. Start. So all of a sudden we have the source code of things. At least while we're inside of the debugger. So it's called std range. Okay, what was the previous example? Control S, project, compile, F9, debugger, start. Step over, step in. Okay, so this is the implementation of the function chain. This is the doc string that we saw online. So when we went dlang doc chain, says function std range, yes, chain, yes, spans multiple ranges in sequence, yes. The function chain, this is preformat code monospaced, so this thing takes any number of ranges and returns a, and this is a D symbol. The ranges may be different, but they must have the same element type. The result is a range that offers the front, pop front, so these things are formatted as code. And then it has the empty, which probably might be navigable or something. Okay. if only one range, how does it say that in here should be an example? If only one range is offered to chain or chain, the chain type exits the picture by aliasing itself directly to that range's type. Parameters, a table, returns an input range at minimum, primitive until here, and then it says see also reference to the symbol only, which is navigable. Okay, to chain values to a range, and then it says example. So these two examples, I cannot see them in the docstring in the source code of std range file. Or this second, third, fourth, fifth example. Fifth. Okay, so auto, it says that the return type will be determined at compile time. This is the name of the symbol function. A list of parameters, and then these are parameters, type parameters. So there's two lists in here. One is values and the others is types. Okay, so ranges is defined in here. This is the type, the uppercase T, as it were in C++ macros. Or C#. In C++ templates. Okay, so this is metaprogramming. Evaluation at compile time. The deprogramming language has a interpreter of a subset of the deprogramming language, and this interpreter is run as compile time in order to generate this specialization, generate code at compile time. Okay, and this if is also a compile time thing. The body of the function starts at this line 893, and these are compile time things. So the name of the range is type, and not only, and then this condition is evaluated at compile time. So it says that the length of this thing should be more than 0, so should have some elements, and this is also a compile time evaluation or satisfy. Is input range static map also a compile time evaluation? Unqual ranges. Common type, static map, element type, static map, unqual ranges. So it's checking this ranges type to make sure that is input range and element type is common type or something. Is not void. Not is void. I don't know exactly how to read this thing. Okay, Static if, this thing is also a compile time thing. If the length is 1, it automatically returns the first value in in rs. So rs is a input parameter, a value, and its type is ranges, which ranges is determined at compile time. Static struct, alias, private, keyword, enum we backed by the type bool. These things are evaluated at compile time. This thing is evaluated at compile time. This is evaluated at compile time. So a ton of metaprogramming in the sense of evaluating the programming language source code at compile time, generating the source code or the abstract syntax trees, and then compiling that thing into the final binary. This is the syntax for properties. Okay, so that was chain, and now we need to go into reduce. So let's step out and then step in again. So now we're inside of reduce. Let's see if we can put breakpoints in here. They should not really work because this is evaluated at compile time, not at runtime. So let's see. Stop, start. So it says template reduce function. Accumulate, compress, inject, full. Template reduce function. So this is the parameter of the type parameters, not the value parameters. This is evaluated at compilation time. Or not. Yeah, this is evaluated at compilation time, and then this is actually the body of the function. Okay, it imports just one symbol static map from this package. Alias for a function. What's binary fun? So fun is a type which is received as in the list of type parameters, whereas binary fun is what? Is a template in std functional. Transforms a string representing an expression to a binary function. So a less than b, binary fun. less, assert less 1 than 2. I don't know exactly what it does, but it seems like it's evaluating this deep programming source code at compile time and generating binary code as a specialization of this thing. So compile time code generation, and then the resulting thing, so function is this less. Static if this is evaluated at compile time, if the type that's in the list of types of this function has a length, whatever that thing is, and greater than 1 at compile time evaluated, then there's need to import tuple, otherwise not. So there's auto reduce RRR, auto reduce SR seed RR. A template isn't a template similar to a mixin or something. So I see private methods defined in here. Let's read a bit. So dlang template. So type T within template lowercase t has a member variable called v. Constraints, specialization, templates must be instantiated. I still don't know what this thing is. So there's a template T copy of type T, and that has inside of it one method, out T2 T from, 2 equals from copy function. To use it, it must be instantiated, otherwise it doesn't know the list of types of this T. So you go T copy, which is the name of that template, and then you say I want to use this list of types, so int, T now is int, and the function copy is out int 2, comma, int from, and it assigns the value of from to 2, and then it returns that 2. So it's a container of functions, this template thing. Okay, seems okay, but then what are mixins? So mixin takes the programming language source code as string, and it generates at compile time the AST, whatever, the binary code for this thing. Mixin of if this thing is evaluatable at compile time, and it is, because this is a string, is passed to this function, its known and compile time is str1, this is known and compile time is write line, parentheses, double quotes, str1, parentheses, double quotes, parentheses, semicolon. So this thing is a string that's known at compile time. So this thing is a string known at compile time. So this thing can be evaluated at compile time, and this thing can be replaced with write line, parentheses, double quote, str1, double quote, str1, etc. Mixin template. It says mixin department string and then 2. I don't know what this thing does. Mixin namespaces, mixin person a dot name. I don't know what this thing does. String mixins. So this is mixin template, and this is string mixins. Here, so it's a compile time compilation started from compile time evaluatable strings. Okay. What else? So the syntax is, there's a ton of syntax in the deprogramming language, and not that easy to reason with what happens here, but then C++ template metaprogramming is also mind-boggling enough. Okay, so we can step into any function using the debugger, but code navigation doesn't take us to the correct symbol if it's not defined in our project. So my sum, which is defined in here, is navigatable by control click, but reduce is not navigatable by control click. So what you can do, you start the debugger and step into reduce if you want to see the source code of reduce and where it's defined, etc. STD range. Just a second. Okay, so I have opened the Visual Studio Code IDE. In there I have opened the directory /.opt/dmd2, and in Explorer Ctrl+Shift-E I'm expanding dmd2, src, phobos, which is the standard library, then std namespace, and then for std.range namespace I'm also expanding range. So I meant tilde/.opt/dmd2/src/phobos/std/range. In here we have 3 .d files. There's interfaces.d, package.d, and primitives.d. So std.range open in Dexed IDE is in fact this file. tilde/opt/dmd2/src/phobo/std/range package.d. Okay, and we're using from std range, we're using chain. Okay, so this thing, line 8, 8, 9, this thing. In order to have syntax highlighting in Visual Studio Code, I used the same wiki page, so wiki.dlang.org/IDEs. It says that for Visual Studio Code, I should install code -d. So I did that. So extensions. In here, I searched for I know what I searched for, code D. D programming language code D. So this thing, deprogramming language, web freak, code D, and I installed it. And then I make sure to start Visual Studio Code from this special terminal, from this special instance of console, where I have the two environment variables defined. So I have created a shell script file, which is called prefix.sh, which exports the two environment variables, LD library path and path. After I source this file, I can start Visual Studio Code, I can start DMD, I can start dub, and I can also start the Dexed ID. I'm not setting these environment variables for my user. I'm setting only as needed in just one terminal. And then I'm starting all of the other programs from there. Okay. Next. We were at parallelism. Control C, Control A, V. Save projects. Let's stop the debugger. Project compile. Debugger. Let's put a breakpoint inside of the for each and before the for each. Debugger start. So it starts the for each parallel. It put a ton of output, and then it could not stop in here at this right line. So GDB could not stop on line 9. How do I force the compilation? How do I clean? How do I rebuild? How do I build? So build this compile project, but then what's rebuild and clean? I don't know. So probably GDB is not good enough to stop on this line, but it's an easy enough theory to test. So let's see. F3. This is the thing. Executable, my project, this guy. Let's open a GDB here. So GDB, correct directory, my tutorial, -2e, my project, C, enter, break in the file, Ctrl-Alt-C, Ctrl-Shift-V, on line 9, and then run. So it could stop here. GDB can break on line 9. So this thing is actually a function which is mangled to _D3 app for main FZ14 __ for each body 1 MFN easy, with two parameters, capture, which is null, and I, which is 5. Okay, just a second. Okay, so using GDB, I executed thread apply all BT full to create backtraces full, including the values of the variables in the parameter lists of method of functions and the local variables. Okay, and let's look at this. So it says that there are 16 threads. So there's thread 1, my project, thread 2, my project, thread 3, my project, thread 4, my project, and the call stacks are source app.d, std parallelism abstract task job, std parallelism submit and execute, std parallelism task this is evaluated at compile time, and parallelism run. And then the function where we broke with a fizzy in mangled name for each range. Iota. Abstract job task run. The next thread is with thread entry point, start thread, clone 3 from glib, see, for 6 threads, and then we're inside of the deprogramming language. So core.thread.context callable opcall, std parallelism task pool start work loop, std parallelism task pool execute work loop, do job, abstract task job, parallelism run, and iota again, and for each pod again. So these are the local variables. This is the, where are you? So this is in with 0D programming source code, thread 3. Thread 4 has deprogramming source language source code. D5 again has the programming language. Has this thing has 0 deprogramming language in the call stack. Oh, it does have in here. So pthread, and so from what I see, in any thread in the call stack, if the function is exported from the C programming language or C++, we have access to its to the name of the file where the source code existed at compile time, the line where the definition of the implementation of the function has started, which we don't have for the deprogramming language. Maybe it wasn't compiled with debug symbols on. Maybe it was stripped. But we have access to this for our deprogramming language source codes for this thing. We have the name of the function where it's implemented. We have the line where the implementation starts. We have the values for the local variables, and we have the values of the parameters. So where we have debug symbols for the deprogramming language, we also have access to the file name, line, local variables, and parameters. But it would have been good if we had a DMD, deprogramming language default implementation compiler, but built with debug symbols. Okay, so we know all of the threads, we know what they do. We can see that at least 11 of them are because iota, because we can see iota in there. So there's iota in thread 16, iota in thread 12, 11, 10, 9, 7, 6, 5, 4, 2, 1. Okay. Can we step into iota? Yes, we can step into iota, so it's in std range, the package. This is compile time. This is the body. So the body says E, which is a type, and end, which is the list of parameters. So this is the list of types and parameters, of type parameters and of parameters. So the type E begin is E of 0, and then return iota, so recursive, begin and end. This is another iota that has as parameters begin and end. This is the iota that has the parameter end, and this is the iota that has two parameters begin and end, if it's integral, and we are integral 11. If it's floating point, then this is the body. If it's integral, then this is the body. If it's pointer, then this is the body. Property, methods, contains length, whatever is this parallel thing. So parallel is in parallelism. STD parallelism. Where are you? It's parallelism.d in Phobos STD. Okay, so this is parallel. So there's parallel for each with 2 parameters, and for each with a range, and that's it. Okay, so I see 4 parallels in here. So there's parallel that receives a list of types, which is R, which is whatever this thing is, and then has 2 parameters, which one is range, which is this guy, and then there's work unit size, so second parameter. This call doesn't have a second parameter. And then there's this, which receives a type, which is the type of this thing, and then 1 parameter are range. So in the deprogramming language, when you say 3 dot, I know, ups, it actually calls ups of 3. So the first do something like what do we comment? Okay, when you say hello world dot write line, Parallelism, I didn't compile. Project. I'll save all. Project. Compile. Okay. So it actually calls WriteLine with the argument this string. Hello world. Okay, so this is a convention in the deprogramming language that it's the same thing if you go a string, a literal string dot WriteLine is the same thing as going WriteLine parenthesis and then the literal string. So when it goes something dot parallel, that thing is probably the same as parallel and then parenthesis of this thing. Let's actually try. Test our theory. Uncomment. Control S. Debugger stop. Project. Save all. Project. Compile. And then start the debugger. So it's the same thing. It created a ton of threads and ran in parallel writing this thing. Okay, so that's why I say that one of these two parallels was called, well, this parallel was probably called this implementation. So there's these two implementations and then there's two more with no list of types. I don't know what's the relationship between these two and the previous two. This just delegate to task pool.parallel. Parallel for each. This is the task type. Okay, so this work unit size, if it's missing, it's in fact 512 or default work unit size. Okay, and then it imports as the exception enforce, then goes enforce and returns whatever this parallel for each of R is. Okay, let's go next. Concurrency. Wow, what is this? Delegates are used to match the message type. Metaprogramming. Templates compile time function execution tuple string mixins. Okay, why is this a metaprogramming? Why is this metaprogramming? It's not metaprogramming. This is not metaprogramming. This is evaluated at runtime. Whereas in here it uses static if, so this all of this is compiled at evaluated at compile time. This is also evaluated at compile time. And you must call it at compile time with an integer. So in fact, it replaces all of this thing with 370 or something. What's the value of factorial of 7? Enum is a way of saying const in the deprogramming language. Type inference, compile time. Okay, so this is calling a compile time evaluated thing, which is factorial, whereas here this is not a compile time thing, but this entire thing can be evaluated at compilation time, compile time function evaluation, because it's used in constant compile time expression. But there are limitations to what you can do in this function. std string format evaluated at compile time. Pragma is used at compile time to show things while the compiler is running at the std out. Let's do this. Import std string and then format. Okay, so in here we don't need to run anything, we just need to rebuild. File, save all, project, compile project. Okay, so the compiler has outputted building my project master, linking my project, where Dub has done this thing, And then the compiler has written 7 exclamation mark space equals space, and then %s, which is factor 7, which is compile time const, which is factorial, which is compile time thing, because this thing is compile time, and 7, which is not less than 2, so recursive call at compile time, etc. So that thing is is 5040, whereas this 9 exclamation mark equals fact of 9, which is also compile time const, fact 9. The type of this thing is inferred at compile time, and then factorial of 9 can be evaluated at compile time because it respects some limitations. Okay, so this is 9. This is 9 times factorial of 8. So this is recursive calls, compile time interpretation, CTFE, garbage collection by default. There is a no GC attribute. Explicit memory management is possible using overloaded operators new and delete. Things can be excluded from the garbage collection, etc. Okay, structs are by default allocated on the stack, and class instances by default allocated on the heap. You can use scoped when you declare an instance of a class to make sure it's cleaned up at when you exit the scope. Static arrays are allocated on the stack. Dynamic arrays. The size of dynamic arrays is not known at compile time. Scope keyword can annotate variables to indicate that they should be cleaned up at scope exit. Save D is a subset. Guaranteed to be memory safe. No writes to memory that has not been allocated or has been recycled. Check that compile time to ensure that they are limited enough not to use things that might corrupt memory. Pointer arithmetics, unchecked casts. Any function called must be marked with safe or trusted. Okay. So the C programming languages ABI is supported. C programming language fundamental and derived types are supported, enabling direct access to existing C code and libraries. The bindings exist for many popular C libraries. C standard library is part of the standard D. D can interface directly with programming languages that provide a C API, such as Python. Extern C++, extern C++ namespace. So extern C++, abstract base class, abstract class base, which is defined, which has interface in C++ but has no implementation. And then you implement print 3i in D programming language. And then print 3. So you need to write a translation layer from the C++ definitions to this thing, D style C++ definitions, and encapsulate that in an external C++ block, and then you can use it. And then there's another subset of the D programming languages is called better C. You have -better C for the DMD compiler. Okay, so open text file, go lines on it, so split by lines, return a dynamic array, and then for each line represents just one word, different word on each line. So this is a for each which gets the first line in the file, which is also the first word in the file. And then it goes whatever chomp is, and then goes to lower. And then duplicates that thing and goes sort. This is a associative array, which is a map, which is a hash map, which is a dictionary. And this is the append operator or something. Words join. similar to other programming languages. Right line. If the length of the word is, if the word is not empty. Yeah, we can do this example. Let's do this example. Control C, Control V, Control S. Where does it find this function with this file? I'm guessing in here. So let's create a file which contains anagrams of other words. I know. Shift F4, Control V. Control S. File, save all. Debugger, stop, project, compile. Debugger, start. Step into. Iteration.d. Linking my project. What is it actually doing? The debugger output. Oh mama. Debugging is not possible. GDB will terminate. Fatal signal segmentation fault. So this thing, segmentation fault, but why? Okay. Break. Control C. Shift V. Line 6. 1. GDB step. I don't want continue. I want step. So it's stepped into. How do we step out? Run. Yes. And next. 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 Continue. There's a breakpoint at line 7. How do we remove that? How do we stop the break? Break file line num. How do we remove the breakpoint? GDB remove breakpoint. Clear. Okay, this thing. Clear. Control Shift V. Line 7. Continue. And it wrote the correct thing and the process finished. Normally no signals were raised. Whereas this has a segmentation fault and fatal sign. So IDEs in Linux tend to use GDB, and the way they instruct GDB what to do through MI or something else doesn't always work perfectly. Sometimes they give such instructions to GDBs that GDB crashes. Which is the case in here. So you don't always get a good debugger experience with the deprogramming language in Linux. You need to resort to using GDB from the command line or the text user interface of GDB. So GDB minus TUI and then the name of the executable. Text user interface TUI. Okay. What if we remove all of the breakpoints? Stop. Then put just one breakpoint in here. Start. Okay. So pure no throw save int up main for each body 4 ref dchar array int stdio lines on apply int delegate ref dchar pure no throw save op apply scope int delegate ref dchar pure no throws and save, and then my function. Okay, so lines and then W. So W is what? Step over. A and A, so a ton of zeros. This smells like, I don't know, UCS4 or something is used for the text encoding. So the text file that we're reading is actually ASCII with \n 0a, whereas the lines and W is actually pairs of 4 bytes, A, then 0, 0, 0, backslash 0, backslash 0, backslash 0, then N, backslash 0, backslash 0, backslash 0. So that's, you know, UCS4, similar to Windows is UCS2, aka UTF-16, little endian with no bomb. So maybe that's the way strings and characters are represented in by default natively in the Linux using the DMD compiler. So operator appends a new D string to the values of the associative dynamic array. Okay. Can we step into this thing? Okay, so this is dup, which duplicates an array such that it's not const anymore or something. So it must be const, the type, the input type, which it is. Okay. And then release and idup. So idup is probably also a function and called with this parameter. And dup is also a function called with this parameter. And signature towards is an associative array, so a dictionary with the key value pair. The key is AAN and the value is in another string. So this iDupe is called with this value as parameter. Stepped into dupe. We stepped into sort. Quick sort implementation. And also probably the visualization through Dexed ID and GDB is not the best for associative arrays, for dynamic arrays, maybe for objects. So signature is AAN. So let's see if we can inspect this value. Control V of AAN. Undefined command. Signature towards. I see that it does a read line, so this seems to be keep reading from the file each time we iterate. So at the next iteration it will read a new line from the file, etc. So similar to yield in C#. Because I can see this F read line that reads from the file. Okay. Exception object EAX. And stepping range. Let's do it again. stop debugger start. So I don't know what's this tut.a.d thing. Stop it. Project compile. Debugger start. Continue. So it writes the standard output that all of the three words have anagrams in the words.txt file, and says that the debugger has finished successfully. Okay. And now let's start doing the tutorial on the official webpage. So the dlang.org